Hello, welcome to another session of Mixed Math. I hope you guys are doing good. Remember I told you the other time that we are going to do more on integrals that require trig substitution. Yeah, though we have solved one example in my previous video, so here too or today too we are going to solve another problem that require trig substitution. To test your understanding, why don't you pause the video and try? Or why don't we get started? So first, let's write our solution. Now this is the integral problem that we are going to work on. Let's bring it down here. Okay, integral square root of x squared minus 1 dx. Yeah, this problem here, I don't know if u substitution will work. Maybe part integration apart, or maybe partial fractions. Well, as for that one, I'll leave it to you guys. You can try other approaches. Maybe it might work for you, but here we are going to use the trig substitution to solve this integral problem. Okay, so as I said, we are going to use trig substitution. Trig substitution. Yeah, to use trig substitution, you need to have a knowledge about trig ratios. I mean sine, cosine, tangent, secant, cosecant, cotangent, etc. Blah blah blah. And also you also need to have an idea about Pythagoras theorem. Pythagoras theorem. We will apply the trig substitution by you apply trig substitution together with what? Pythagoras theorem. So if you don't know how Pythagoras theorem works, you will find difficult what applying this trig substitution method. Okay, so to use the trig substitution approach, first we need a right angle triangle. Not just any triangle, but what? Right angled triangle. Then with that right angle triangle, after you have positioned your theta, I don't know where you're going to position it, but you'll find out at the end of the day in this video. After positioning your theta, we are just going to, not the square root, but we are just going to write these numbers or this variable and this figure here on the size of the right angle triangle, basing on the application of what? Pythagoras theorem. Okay, so first let's draw a right angle and let's see how these variables here or these ones here can be written on the size of the triangle. Okay, so let's draw a right angle triangle. Yeah, our right angle triangle here is like the symbol for the 90 degrees, and by the way that this one is vertical, beating this one is what? Limiting this horizontal eventually or ideally produce 90 degrees angle. So we shouldn't worry much about the symbol. It's a right angle triangle, and even with that symbol, you can still tell it's a right angle triangle. So let's here I'm gonna put my theta here. Now mind you, the position of the angle, I mean where you position your theta or where you locate it is very, very important. Apart from this side, either this or that side, you can locate it, but it's very, very important because the position will tell the names of the sides of the triangle, with the exception of what? The hypotenuse. The opposite and the adjacent size identification depends on the position of the earth angle. If the angle is positioned here or the angle is here, then this side is what? The opposite, because that is the side facing the angle. And then this side is the adjacent, because that is the side the angle is what? Resting on, or the adjoining to what? The side that is adjoining to what? The angle. Okay, so, or if you position your angle here, this line is no longer the opposite, because here, when the angle is here, theta is here, the theta is resting on what? This line. So it does not make this line what? Opposite. The opposite is always the line that is what? Facing what? Angle theta, or maybe any variable that we use. That is the line. Opposite line is the line that is always what? Facing what? The angle. And the one that the angle is resting on is what? The adjacent. And then, and this line, the position of the angle does not affect what? The name of this line. This line here is the hypotenuse, because that is the line, or that is the side facing the 90 degrees what? Sine, or facing what? The 90 degrees angle what? Here. So if you position your angle here or there, that will not affect the name of this one here. But if it is here or here, it affects the name of what? This side and then this side. But don't worry, in our video I'm gonna put the angle theta what? Here. Okay, so let's put it there. Okay, so our theta is being located nicely. Now that theta is here, this line is our what? Adjacent, because we can see theta is resting on this, and then that, but this one we don't bother ourselves on it. The most important part is what? This, knowing this, and then this part. Okay, so this one is resting on this one, so we are going to call it what? The adjacent. And what is this? What line is facing this one? That is this one. You see, that is the line facing it. Okay, so this one become our opposite, and then this one become our adjacent. This one is what? Our hypotenuse. So as I said, we are going to apply or write the x squared minus 1 on the sides of the, when I made this side, I mean this side, and this side, based on what? The Pythagoras theorem. Now, square root of x squared minus 1, you could see that, with Pythagoras theorem, assuming here is A, and then here is B, and then here is C, the theorem states that c squared is equal to a squared plus b squared. And if you want to find c will be equal to square root of a squared plus b squared. Okay, now c is there, b is there, but a is not there. To find a is equal to, a squared is equal to c squared minus what? B squared. And when we take square root of what? A, we're gonna get a is equal to square root of c squared minus a squared. So referring back to our question, which is square root of x squared minus 1, x is going to be on the hypotenuse side. It's going to be what? The highest. We are going to position x what? Here. And then we will position the 1 on this opposite side, on this opposite what? Side. So x will come here, and then 1 will come here, and then we will position what? When the x is here, that will give us what? X, and then here will be 1. So to find this side is what? X squared minus what? 1 squared. And x squared minus 1 squared will give us what? X squared minus 1. So what is this side? This side is equal to what? The square root of x squared minus what? 1. Okay, so that is this side here. You're gonna get x squared minus 1 for this side. And as I said, our x is coming here. So there is our x here. And then there is our what? 1 here. Okay, so to get this side, as the Pythagoras theorem, as the theorem states, we just square this one, subtract this one from this, after which we take square root of that, and that will give us what? The value of what? This line. Okay, good. Now, when you are done writing the numbers or the variables on the sides of the triangle, uh, there is, after writing them on a triangle, what is left is you are now going to what? Use the triangle to what? Generate your what? Ratios. Or yeah, to generate your what? Ratios. Under trigonometry, we have formulas for those ratios. We have sqrt, we call it sqrt. So we are going to apply the sqrt here on this right angle triangle. Then we find out which of them is very simple to use. When you apply the sqrt here and realize that all of them are going to be very complex or something else, then we opt for their what? Reciprocals. When I say reciprocal of sine is what? Cosecant. That is 1 over sine will give us what? Cosecant. 1 over cos will give us what? Secant. Okay, so we are going to generate our ratios. All of them are what? Part of the ratio. So if the main ratio doesn't work, then we opt for their what? Reciprocals. Okay, so now when you are generating your ratios, always opt for those ones that are what? Easy to differentiate. When we pick sine is opposite over hypotenuse, this side over this side. It won't be though it will work, but it won't be all that easy to differentiate. Manipulating will be very difficult. Okay, but let's say what about when we pick tangent? Tangent will give us what? Now here will be what? Square root of this over there. That is opposite over what? Adjacent. So it's going to be this one over there. So that one will give us what? Square root of x squared minus 1. It's cool, but so differentiating this one won't be. It's easy, but not all that easy. You're gonna spend some time to work on it. Yeah. But what about cosine? Cos will be what? 1 over what? X. 1 over what? X. That is, cos is k adjacent over hypotenuse. So when you apply the formula here, you're gonna get 1 over what? X. 1 over what? X. So cos is equal to 1 over what? X. And to differentiate, we want x, we want to find what x will be equal to. So we are just going to reciprocate both of them. Okay, so when you reciprocate cos, you're gonna get what? Secant. And secant is the reciprocal of what? Cos. So if cos gave us what? 1 over x, secant will give us what? Reciprocal of 1 over x is what? When I say reciprocal, if it is a over b and you are to reciprocate, it means bring the b up and take the a down. Okay, so 1 over x in its reciprocal will be what? X over 1. Okay, so cos in its reciprocal will give us what? Secant. So here we're going to use what? Secant. So secant theta is equal to x. Secant theta is equal to what? X. Okay, you see this one is very simple to work with as compared to this one over this or this one over that. Okay, though cosine gave us 1 over this, and if you want to find x, probably it's going to be x cos theta is equal to 1. Then we divide both sides by cos theta and we get x is equal to 1 over cos. 1 over cos is what? The secant here. So if you want to take the secant directly from here, it's just secant is equal to adjacent hypotenuse over adjacent. Okay, so secant is equal to this side over this side. Okay, all right. So now let's differentiate. The derivative of secant theta will give us what? I think that will give us secant theta tangent theta. When we integrate secant theta tangent theta, we get what? Secant theta. Okay, so this will give us secant theta tangent theta the theta, and is equal to what? The x, and is equal to the x. All right, so we know that the original, when you go back to the original integral, this one will replace what? X, and then this one will replace what? Dx. And also we can still find what is going to replace the whole square root of x squared minus 1, still by using what? The ratios. Now let's look at tan. That is Twi. Twi will be opposite over what? Adjacent. Opposite over what? Adjacent. Let's find out. So tan theta is equal to opposite. What is the opposite? The opposite is this one, and the adjacent is this. So tan theta is equal to what? This one. So we can replace the whole of square root of x squared minus 1 with what? Tan theta. And at the end of the day, when we substitute this one here, the answer that we are going to get after taking the square root is going to give is going to be what? Tan theta. Okay, so if you want to go fast, you can apply the ratios, one of the ratios, to replace the whole of what? That square root x squared minus 1. Okay, so tan theta will be equal to square root of x squared minus 1. But here I didn't include that side here. We are going to put x is equal to theta into the square root into integral r squared minus 1, and then we deal with it in bit, or we solve it in bit, so that we will know that how each answer is going to be arrived. Okay, so let's put them into the integral. Good. So when we replace x with secant, this is what we are going to get. You're gonna get secant theta squared minus 1 multiplied by this one is equal to this. So when you put it, you're gonna get secant theta tangent theta, the theta. Okay, so this one will give us, from trig identities, 1 plus tan theta squared is equal to secant theta squared. So if you are having tan theta is equal to secant theta squared minus 1, so this one is equal to tan theta squared, and then we multiply it by this one. All right, so you see, after here we have gotten our tan theta squared multiplied by secant theta tan theta the theta. Now these two will take away the square root sign to be left with what? Tan theta. You see, I told you that we can replace the whole of square root of what? L squared minus 1 with what? Tan theta, because tan theta is what? Opposite over what? Hypotenuse. And when we do that, we get exactly what is in the question, or what we are supposed to what? Integrate. So we could have just replaced square root of x squared minus 1 with tan theta, and then we multiply by the multiply by this one, because this one is replacing what? Ds in the theta world. So I choose to do it this way just to confirm what I said about generating, trying to um, 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 replace the whole of square root of x squared minus 1 with one of the what? Trig ratios. That is what? Tan. That is one. I just did it to confirm that at the end of the day, if you don't do it that way, and even you substitute and work it out, you're just going to get the same what? Answer. So here, this time, this will give us what? Tan theta squared multiplied by secant theta the theta. Good. Here, before to continue, we know that we cannot, this one is an integration apart question though, but we're not going to apply that integration apart question here directly. Tan theta squared is equal to secant squared minus 1. So you're going to replace this one with what? Secant squared minus what? 1. Okay, when you do that, this one is the same as tan theta here. So this one multiplied by this one will give us what? Secant raised to the power 3 the theta minus secant theta the theta. Alright, now let's separate it or let's split it. Okay, integral secant to the third raised to the power 3 the theta minus integral secant theta the theta. Here we are going to solve them separately. We're going to solve them separately. You call this one A and then call this one what? B. Okay, so you're going to start with what? A. Integrating this one is very confusing, but you just take your time, follow it very closely, and you'll get it. Okay, don't just get confused, just follow what I'm going to do, listen to whatever I'm saying, just apply them together with the workers that you are watching. You could see that I don't know they are gonna what get it. Okay, and this one reflects one of the ways of using what DI method, where we stop. Okay, so that one is going to be reflected here, or is going to be illustrated here. Yeah, it's going to be what illustrated here. Okay, so you just don't worry, and then at the end of the day you're just going to get it. So let's bring it down here. We are calling this one A and then this one what? B. Okay, integral secant raised to the power 3 theta the theta. We are going to split it into two. That is secant theta squared times secant theta. Okay, so secant theta squared times secant theta the theta. Here we have split it into two because you're going to apply what? Integration what? Apart. Integration what? Apart. So by the integration apart, I'll be using the DI method. When you look at these two, all of them are not that easy. When you integrate this, we know answer to this one. When we integrate, when we differentiate, we are just multiplying our problem. And then when we integrate this, another issue. So you are going to differentiate this one. When you differentiate this, we had, I think it will give us secant theta tan theta. And then when we integrate this one, you're gonna get what? Tangent theta tan theta. Okay, so let's integrate this one then differentiate this one. Okay, so let's draw our format. So the DI method, so we are differentiating this one and then we are integrating what? This one. Just take your time and just follow, you get it. Okay, when you differentiate this one, the next column you're gonna get secant theta tangent theta, and then here will give us what? Tan theta. When you integrate this one, tan theta. You already know how the reason why when you integrate secant theta you get tan theta. I've already done a video that I've already give a proof of why when you integrate secant theta you get tan theta. But if you want to know why, if you wish to know why, if you want that video to watch or to find out, you don't worry, I'll just leave a link in the description below. So maybe after this one, and if you want to know why they say integral of this one is equal to this, then maybe you go and click on that link and then just enjoy yourself with that video. Okay, so here we are going to stop. We are not going any further because when we integrate this one, it will give us another answer. When we differentiate this, we are not going to get any zero in the D column. Okay, but there are three ways: either getting 0, the original repeating, or easily getting the product of the row being easily what integrated without using a DI method what again. So they're gonna, apart from getting 0, you're gonna apply one of them. The other approach, that is either getting the product of the row being repeated. Now when we multiply this and this, the product of what this row, you see the product of this row give us the same thing as compared to the other one. It was tan theta multiplied by secant theta tan theta, and then they became secant to the third power theta d theta minus integral minus what secant theta, something like that, right? So if we have gotten the same thing here, it's a matter of the original being what repeated. Okay, so when we multiply this and this is equal to something in our previous working, which we can add it to it, divide both sides by whatever we get, and then we get the answer to it. Okay, that's why I said very confusing, but you don't worry, you'll get it at the end of the day. Okay, all right, so this is how you're gonna get our answer. You already know product of what diagonal, so this times this one will give us what the first part of what our answer. So that is secant theta times tan theta, and then the product of this row, when you multiply this by this, you're gonna get tan theta squared secant theta d theta, and the minus is here because this row is what negative. And as I was saying, the product of diagonals are your what answer. So this times this one, which is indicated in this blue out arrow, gave us what this, and then we had this because of the product of what this one, and then the whole of what this one, which is in what this red what parenthesis. Always what is in the red parenthesis is what we further what work on. Okay, so there is what we have gotten, and we are going to further work on this one, but actually we will not further work on this any no work on it ideally. We're just going to add it to it equally, and then we just find what we get, and then divide both sides by what 8. Okay, so this one the same as usual. Let's replace it with secant theta squared minus 1. Okay, when we do that, what are we going to get? Now let's open the bracket. Okay, this is what we are integrating. And the answer to this one is what? This one minus. Now when you open the bracket, you're going to get, remember this minus here is affecting the whole of this one. So this one will give you this one, and then this one will give you what? This, but this minus here is affecting all of them. So minus integral secant raised to the power 3 theta d theta. That is good. That is why we had this, and that minus integral secant theta d theta, and that will give us what is positive what integral secant theta d theta here. It's because when we open it, this minus is affecting everything. So when we open this one and apply the minus, multiply the minus through, this is what we are going to get at the end of the day. This and this will give us secant raised to the power 3 theta minus secant theta. And when we multiply the minus through, in terms of splitting, we are going to get, since minus is here, you're going to get the next one to be what? Plus. Okay, good. I brought this one here. This is the one that we are here. I brought this one here because we have gotten something which looks like, or which is the same thing as what this, so that we can bring that something to what this one. We can come and add that something to this one, of which we divide both sides by whatever we get, and then we get an answer for this integral. So this one is not actually the exact answer to this integral. There's something that we have to do. We have to take this one to this side, divide both sides by whatever we get, and then whatever we get will be our what answer to this what integral. Okay, so this one is equal to the whole of the, but you could see that this one is the same thing as what this. So this one is what negative. When it crosses the equal sign, it will become what positive. So when it comes here, it will be this one plus this one, and it will be what 2. So we are going to get 2 integral secant raised to the power 3 theta what the theta. And then what is the answer to this integral secant theta the theta? Good, the answer to this one is what? Natural log absolute value of secant theta tangent theta. But you don't worry, this one, remember where we splitted them, we were having A and B. This one is the same thing as well, the B part. Okay, so this I'll just write the answer for you, that when we are solving the B part, I will show you how I got the answer for this one. Okay, but here I'll just write it directly for you guys. Okay, so we just go and add this one to this one, and when you do that, you're gonna get okay. So as I said, I'll write answer for this one directly, and that is natural log absolute value of secant theta plus tan what theta, and you know why when you are solving the B part. Okay, so this plus this will give us what? I think 2. That gives us 2. Okay, 2 integral secant raised to the power 3 theta with theta is equal to secant theta tan theta plus natural log of absolute value secant theta plus tan theta. Here we are having 2. So what are you going to do? I'm just going to multiply. Sorry, you're just going to multiply both sides by what? 1 out of 2. And when you do that, this one will be equal to 1 over 2 secant theta tan theta plus 1 over 2 natural log of absolute value secant theta plus tan what? Theta. Okay, so the answer to this integral is what? This one is this one. That is how 1 over 2 secant theta tan theta plus 1 over 2 natural log absolute value of secant theta plus what? Tan theta. Okay, now this is the answer to this one. So let's move on to the B part. Don't worry, you add our answers together when we are done with the B part. Okay, with the B part, I'm gonna show you how I got the answer to this integral in the other section. So here we are going to multiply this one. This secant theta here is what? Over 1. So we are going to multiply both top and down, that is both numerator and denominator, by what? Secant theta plus tangent theta. Okay, to integrate this one, or to give a proof of why the whole of this one is equal to natural log absolute value secant theta plus tangent theta. That is what I'm going to show. Okay, so here I'm going to multiply both numerator, and then this one is over 1, so both numerator and denominator by secant theta plus tan theta. So let's multiply. Okay, so This is what I'm talking about. So this 1 over 1 times this one, you're going to get, now when you multiply this by this, you're going to get secant theta squared plus tan theta squared divided by this time. This will give us what? Secant theta plus tangent theta. Okay, so here you're going to do substitution. You're going to do substitution. You're going to let u be equal to this one, that is secant theta tan theta. Then we differentiate. Okay, so let's differentiate. Du is equal to, now when you differentiate this, you're gonna get secant theta tan theta, and then when you differentiate this, you're gonna get secant theta squared, or what? The theta. Okay, so let's find what is going to replace what? The theta. So the theta will be equal to du over the whole of this. Okay, the theta is equal to this one, and then we know that u is equal to this one. So let's put them into the integrals and then let's continue. Okay, secant theta plus secant theta squared plus secant theta tan theta over u times 1 over secant theta plus secant theta plus 1 over secant theta squared plus secant theta tangent theta. That times, yeah. Here, this one will cancel out with the whole of this one. It will be left with what? 1 over u, 1 over u. Now, what is the answer to this integral? You're going to get natural log absolute value of u. Natural log absolute value of what? U. By u is equal to what? By u is equal to secant theta tangent theta. So let's put it there. So you're gonna get natural log secant theta tangent theta. So that is why the other part I had this as the answer to that particular integral. So I wrote it there directly just because I will be showing you how I had my answer in this part. Okay, now that we have gotten answers to both of them, let's add those answers together. So answer to A and then answer to B, we are going to put it what? Together. Okay, so let's add them. Okay, this one is the A for A part, and then this one is what? B. That is the one we just had here. So we are having 1 over 2 secant theta tan theta plus 1 over 2 natural log absolute value secant theta plus tan theta minus natural log absolute value secant theta plus tangent theta or tan theta. Now you could see that this and this are the same. Look at this. Here having secant theta tan theta, the same absolute value, the same natural log. When you come here, secant theta tan theta, absolute value natural log. Okay, this means that they are the same. So since they are the same, we can add their coefficient. We can add or subtract their coefficient. So 1 over 2 minus the coefficient of this one is what? 1. So 1 over 2 minus 1 will give us what? That will give us what? Minus half. So our answer to this one is equal to 1 over 2 secant theta tan theta minus 1 over 2 natural log absolute value of secant theta plus tan theta. Okay, now that is the answer to the integral question in the theta world. What is the answer to the integral question in the x world? As the question is what? Expressing. This is not a definite integral where we are just going to put the values indirectly and then we compute to find our what value at the end of the day. This one is indefinite, so when we are done, we have to go back to the u word because the question didn't state what we are supposed to do. So let's go back. So going back to the x word, we know that secant theta is equal to x and tan theta is equal to a square root of x squared minus 1. Okay, so let's replace secant theta and tan theta with what? This one and then what? X. So integral square root of x squared minus 1 dx equal to 1 over 2. It was secant theta, right? Secant theta is what? X, so that is the x here, times tan theta. So what is tan theta? Tan theta is what? Square root of x squared minus 1. So that is this one what? Here. And then minus 1 over 2 natural log. Here it was secant theta tan theta. And what is secant? That is there are x here plus tangent. Tangent is what? Equal to this one here. Okay, so the answer to this integral question is what? 1 over 2 x multiplied by square root of x squared minus 1 minus 1 over 2 natural log absolute value of x plus square root of x squared minus 1. Okay, but you know the law, we are not done, so let's add our plus c to complete what? Everything. So therefore this integral here is equal to the whole of this one plus c is equal to the whole of this one plus is equal to the whole of this one plus c, the whole of this one plus c, the whole of this one plus c. Yeah, I know it might confuse some of us, but you don't worry. As we are solving more examples, you get to know every trick, every trick that is involved in using what? This approach. You don't worry, as time goes on, you get to understand everything. Yeah, yeah. So all right, so guys, the answer to this integral is what? 1 over 2 multiplied by x times square root of x squared minus 1 minus 1 over 2 natural log absolute value of x plus square root of what? X squared minus 1 plus what? C plus C. Alright, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.